Take it away.
Okay, good afternoon, everybody. My name is Shai Tsur. I'm with the infrastructure line of business at ARM, where I work with the ISV community around NFV specifically. What I wanted to talk to you today about the ARM-based approach to CPE. Kind of taking a step back, and some of you who saw my colleague Bob Monkman's keynote yesterday recognize this slide. But the infrastructure group inside ARM is tasked with looking forward at a world, 12, 15 years from now that has 1 trillion connected devices in it. Those devices will need to be networked, talk to each other. And for that to happen, we'll just basically need new networks, new edges, just a new way of looking at things. So the task of the infrastructure line of business is to work to pull together the whole ARM ecosystem around networking. So this involves our partners, our hardware partners who are actually building out ARM-based SoCs. It also involves the software community, both the commercial ISV community and the open source projects that we help lead, things like OPNFV, Acrino, ONAP, et cetera. With this idea that as ARM develops, so we take our know-how that we've been working in the world of, say, the radio and access piece of it, and then building the network for the future from the edge in. So as these networks get built in, edge in, they will need new architectures, and then we'll need hybrid capabilities. So at each step of the way, there's going to be a different combination of CPU, GPU, machine learning, et cetera. And we believe that this is where ARM can really come into play, considering the value of the ARM architecture is its flexibility. It's the power efficiency, it's the multi-core capabilities, it's the hardware offload capabilities. And we are working with our partners to create and come up with the right combination of hardware and software that will allow us to build out this and unleash this network. So what I would like to focus on today, and a lot of the work that I have been doing over the last year or so, looking at the edge, is really the CPU, the CPE use case, and the universal CPE use case specifically, because we believe this is an interesting place where ARM can play. So I mean, there's been a lot of talk in different forums here over the last couple of days talking about universal CPE, usually in the framework of how can we make money off NFV, which seems to be one of the ongoing themes of the conference. But universal CPE is one of these areas that seems to be gaining the most traction in the NFV world, precisely because this comes from the interest of both the service providers who are looking to deploy new services to their customers in new ways and new business opportunities, and those same customers who are looking to get a better mix of functionality without having to deal with the vendor lock-in from the incumbent vendors. So the fact that you're trying to provide new services in a universal manner means that in order to be effective at it, you as a service provider need to be able to provide your end customer, with a box that looks something like a white box server that's open, that can run a variety of different software from different vendors. Now, this, as I will detail in a bit, presents a bunch of new challenges, both in terms of performance and in terms of cost and in terms of security, that we believe ARM is very well positioned to deal with. So I'm going to use as our case study here the work that we've done with telco systems. So I've been working with telco systems on universal CPE for a bit over a year and a half now. Back this time last year in The Hague, we showed off the first prototype of an ARM-based universal CPE platform, which was based on the NXP SoC chipset. At Barcelona in February, we debuted a second platform based on Marvell's Armada SoC. And this year, we're actually showing the first GA version of the box. So this is operator ready, based on the NXP LS2088 platform, and is running a number of VNFs, 6WIN's virtual router, Trend Micro's security solution, the FatPipe SD-WAN. So this combination of routing, firewall, SD-WAN gives us kind of a full suite of hardware that's available to be tested. And this is managed by the telco system's NFVTime-os. So just in terms of the architecture, so this is an interesting combination that shows kind of all the work that we've been doing in the ecosystem kind of coming together. So we have a number of ODMs that are working with the number of SoC partners that are involved in the project. The telco systems solution is a combination of both open source components, OVS, KVM, OpenStack pieces, and their own proprietary management suite for the lifecycle management of the universal CPE. So this is all the zero-touch provisioning, the high availability, and everything you'd expect from kind of a carrier-grade universal CPE solution. And on top of that, we have the VNFs that have ported over to this platform and are taking advantage of the particular advantages of the SoCs, the underlying SoCs. So this is taking advantage of the hardware acceleration and offload features, as well as the security that is provided by the ARM Trust Zone. So let's go back to the idea of the UCPE challenges. So as we said, from the service provider perspective, you are now deploying, instead of running the VNF centrally, you are now running the VNFs on-prem at your customer, and providing the customer with an open platform that the customer can mix and match from a variety of both commercial and open source functions running on that box. So this presents this idea that you're providing an open system presents some interesting challenges, both when you're looking at the economics of the universal CPE and operationally the security concerns for that box. So if we take a look at the TCO issue, I think it's been well mentioned that running one VNF on a UCPE platform is not economical, so the numbers don't work. So you need multiple VNFs running on that box from the service provider perspective in order to make the economic case for the service that you're offering your customer. So this means that the cost of the box itself versus the number of VNFs that can run on that box becomes a factor. And in fact, we heard this morning, I think Adva was talking about the fact that you start off with a small 4-core box, and that has very limited functionality, but that allows you to upsell to an 8-core box. So it's this sort of thing from a vendor perspective that I'm not sure that the service providers themselves really like. At the same time, we're moving to open platforms. So in a world where there were closed proprietary platforms coming from different vendors, when you had the dedicated devices, you could count on the vendors to provide the security platform, and it was hardened. Now we're coming up to a much kind of more challenging world where you have different VNFs running from different partners, and those boxes themselves are no longer centrally located. So as a service provider, you've kind of lost the control that you would have had if you were running the VNFs centrally, and you need to deal with all sorts of security considerations that could come from different areas inside the software. And so we'll kind of look into how the advantages of the ARM platform can address both these cases. So let's talk, like we said, about the TCO capabilities. So I think one of the interesting, I think one of the big value propositions for ARM is our ability to leverage multiple cores, or kind of a much greater number of cores inside a given price or power envelope. And this becomes an advantage when we look at the cores necessary to run your universal CPE platform. So what happens in a UCPE platform is that the NFVI itself generally monopolizes one of the cores, and they need another core dedicated to OVS DPDK. So in a 4-core box, that would leave you with 2 cores available for running VNFs, and that would greatly limit the number you could run. In the various ARM SoC platforms, we have the hardware offload capabilities that allow you to free up one of those cores that would otherwise be used for the OVS DPDK. And therefore, instead of having, on a 4-core device, instead of having 2 cores, you have 3 cores to run VNFs. You can run a greater number of services on that same box and that same number of cores. In addition, because of the price and the power advantages, in a lot of cases, for the same, say, power envelope or the same kind of price range of a 4-core competing system device, say the sort of Adam Denverton Rangeley family, you can get an 8-core NXP device. So now you've got an 8-core device that's sort of in the same kind of price range as a 4-core device. It already has the hardware offload capabilities, and now you have 7 cores available for running VNF. So this really kind of makes, when you're looking at the pricing of it, and we're looking about what you can, the number of services, the amount of services you can give to your customers, this becomes a much more compelling proposition. So we believe that this idea of multiple cores, multi-core solution plus hardware offload really will drive the universal UCPE TCO, too many acronyms, and that this will actually become more pronounced. This is the world of today when we're talking about KVMs or virtualized VNFs, and I think when we're looking forward to a world when you're running a lot of containerized VNFs, then the multi-core environment will become even more of an advantage. So the second issue, as we said, is security. With a multi-VNF environment running on the customer premises, you lose a lot of control of the security, and you open up a lot of areas for malicious actors to attack the system, both from the software and the hardware perspective. When we're looking at UCPE Security, so there's, you can see sort of 6 factors or features that you could tackle the problem with. From the ARM perspective, and a lot of the work that we've been doing together with our partners involves how to utilize the ARM's trust zone features to provide unique security features for the universal CPE. So ARM has a security feature called Trust Zone that allows you to partition off essentially areas of the firmware that are secure. So it's a secure subsystem, which we would call a trusted execution environment. So you have a secure world, what we would call in the non-secure world, and non-secure world has very limited access to secure world. So you can, things like DRM licensing and other secret information you can kind of keep on the secure platform. And in doing that, it allows you to provide features, especially with regards to the booting process, with regards to the life cycle management and the zero-touch provisioning, and even the interaction of the VNFs that are running concurrently on a device. So let's have a look here at the hardware through the boot up process. So from the moment you power up the device through to, boots up the hardware, boots up the kernel boots up the NFVI, and then the VNFs run on top of that. And at each stage of this process, either, a malicious NFVI or malicious VNFs could be brought into play here to hijack the device, to run DDoS attacks, to grab credentials, all sorts of things. So this becomes there are numerous security holes here. What we are working on with the NFVI is to use the trusted execution environment to create a set of cryptographic keys that will create what we call a root of trust. So you have a basic root of trust mechanism, basically signatures, that can be used to verify each stage of this process. So, as we go from the power on all the way up to the NFVIs being run, you can do the checking of the cryptographic keys, and in case of root of trust failure, you can then fail over to some kind of safe mode. So the device itself becomes a lot more secure at the hardware level. And you can take this same approach to the world of the zero-touch provisioning. So what you can see here is the telco systems platform has what they call the NFVTime, the UCPE management, which is the centralized lifecycle management part of the solution that once the box is delivered to the customer premise, connects to the platform. The latest version of the OS is provisioned on the device. The UCPE is provisioned inside the network, and then the VNFs themselves are provisioned on that device, and the service function chain is established. And again, malicious software could attack pretty much every, other than the physical delivery of the device, every other stage in this process is a potential security hole for bad actors. And so again, you can use the trust zone to create very kind of hardware-based authentication mechanisms that would ensure that the whole zero-touch provisioning process of that is going to be secure and verified. And then another concern that we are looking at right now, this is a bit more future-looking, but if you have multiple VNFs from multiple vendors running on one device, how do you keep one from attacking another? So, stealing DRM credentials, changing the configuration of the other VNFs, et cetera. And we are looking at ways of using ARM's trust zone to essentially kind of partition off, just build kind of secure walls between the VNFs in order to kind of manage the access from one to the other a lot more effectively. So I'm going to conclude here. So when we're looking at where, we're talking about sort of an ARM-based approach to universal CPE, it starts off with the fact that the ARM ecosystem is very varied. There are a number of different players involved, each having their own catalogs of different core count SoCs with different capabilities in terms of acceleration and hardware offload and security. And when we're looking at a universal CPE, this is a way to really customize the experience, customize the hardware to the business services that you are trying to solve for in a much more cost-effective way. So you can come up with solutions that are for the same, again, price-power envelope, are much more cost-efficient with a better level of performance and a much higher level of security. And this is what we believe is the way forward. So you can see the demo. We've got two, you can see the UCPE and demo both in ARM's ecosystem zone. So we have a zone downstairs that highlights some of the work that we're doing with various of our software partners, including Telco Systems. So you can see a demonstration of that device there, or you could see that booth at their booth as well. Okay. I have like another couple minutes if anybody's got sort of questions or comments in the back. So you can, from the ARM platform, you can, our SoC partners, when they're building the SoCs, so ARM licenses out, so we're an IP company, we license the base CPU design to partners such as Marvell or NXP, Qualcomm, et cetera, who take that and build the SoC around that. When they're building the SoC, and each partner has a different way of doing it, you can offload things like IPsec, cryptography, crypto acceleration, things like this to the hardware, the SoC platform itself, which frees up, instead of doing it in the CPU, you're doing it accelerated on the SoC itself. Thank you.